today we are in section 1.2, and we're going to look at algebraic expressions and models. Starting with a numerical expression first. A numerical expression has a few things in it. It has numbers. It has operations, which are things we do to numbers, like plus, minus, multiply, divide, powers. And it has grouping symbols, which are parentheses. They could be our normal rounded parentheses. We can start using square brackets or fancier brackets, but it just has those things. The important thing that it does not include is an equal sign. Okay? A numerical expression does not have an equal sign. Once we bring an equals into something, that's now called an equation. Okay? So a numerical expression does not include an equal sign. It also does not include any letters. Okay? It should just be numbers. The next thing is just kind of a point of order for something that we all say wrong, and me too, and I will continue to say it wrong because that's how we're used to saying it and hearing it, so it'll sound weird otherwise. But we say things like 2 to the power of 3, which is not really right. The power is actually the answer to an exponent question. So if I'm doing something like 2 to the power of 3, which is 8. 2 is called our base, and 3 is called our exponent. So 3 is not called a power. The answer to that whole thing is a power, which is 8. Okay? I'm still going to say stuff like 2 to the power of 3, because that's what you're used to hearing, and you'll know what I mean when I say that. But you also need to know what I mean if I'm talking about a base or if I'm talking about an exponent. Okay? The base is the bottom number, the exponent is the little number at the top. Technically, the power is really the answer to the whole thing.
You say 2 is the exponent.
Yeah, the right way to say it would be like 2 with an exponent of 3. But that just sounds weird because we're not used to it. Order of operations are something that you're hopefully familiar with. We do our parentheses first, whatever's inside of parentheses, and if there's more than one set of parentheses, we go all the way to the inside and work our way from the inside out. Within that, we also do our exponents next. We then multiply and divide, and this is important. Multiplication and division is one step. So we don't go through and multiply and then go back through and divide. Okay? We start at the beginning of the problem, and we do all of the multiplication and division together at the same time in the order they come. Same thing with addition and subtraction. We don't go through and do all the adding and then go back and do all the subtracting. We start at the beginning, and then anytime we hit an add or subtract, we do it. Okay, as that last step. So that's a common mistake that students try to do those as separate steps. There's really only 4 steps. There's parentheses, there's exponents, multiply and divide, add and subtract. There's really only 4 steps. Some people remember it by just the acronym of PEMDAS or by the little phrase, please excuse my dear Aunt Sally, whatever works for you to remember what order you're supposed to do things in. Order of operations is the way that we always do things. So you don't just do it as the directions say, use the order of operations. That's just the way numbers work. So that's the way problems should always be solved, even if it's not specifically stated. All right. These 2 problems look extremely similar, but there's one important difference with those parentheses. They make this problem mean something different. When we have those parentheses there, that means we are going to take that base of -3 and multiply that base of -3 4 times. When we do that, we get 4 negatives, so that makes it positive 81. When we do not have the parentheses there, that means that we have a -3 multiplied 4 times. The negative does not take on the exponent. An exponent is only applied to whatever is closest to it. So the exponent is applied to the 3, but not the negative. In the previous one, it's applied to the negative as well because they're all grouped together there. Okay? So in this one, there's only 1 negative. So our answer is -81. Students run into a big problem with those parentheses on their calculator. And I get a lot of times that a student will get a wrong answer and they'll tell me, but my calculator said, like, I believe you. I totally believe that's what your calculator said. The problem is you didn't type it in right. So it's going to give you a wrong answer if you don't type it in right. So it's really important to understand the difference that those parentheses can actually make it a problem. Okay? Questions? Go ahead and do these two. Okay, so in the first one, that negative is included in the multiplication. So I have 6 negative 2's all multiplied together. So 6 negatives makes a positive, and then those 6 2's makes 64. Whereas in the next one, I just have the 1 negative and then 6 2's. So that one gives me a negative 64. So I don't mind calculator usage. I use my calculator a lot, but just make sure that when you use your calculator, you're using it appropriately and properly. And if the problem has parentheses, you need to be putting those in your calculator because they can make a difference. Okay. Questions? Evaluate. When we're evaluating these, we're going to use our order of operations. So starting on the inside of parentheses first. So the first thing I'm going to do is negative 2 plus 5, which is 3. Parentheses, exponents are the next step of the order of operations, and exponents are just applied to the thing closest to the exponent, just to that base. So that exponent of 2 is only applied to the 3. 3 squared is 9. Then we multiply and divide. So 2 times 9 is 18. Then we add and subtract, which gives 14. You do not need to show all of your work all the way through if you don't want to. I just like to, especially while we're emphasizing order of operations, show each specific step of the order of operations, but you don't have to if you don't need to.
If we type it in like exactly how it's written, our calculator will always come out with the right answer.
Yes, the calculator understands the order of operations, so as long as you type it in exactly like it's written, then you'll get the right answer. Go ahead and try number 6.
Which is 1 plus 3, which is 4.
So we start inside of our parentheses. 1 minus negative 3. Double negative is plus, so we get 4. Parentheses exponents. So then we get 4 times 4 times 4, which is 64. Then multiply. 5 times 64 is 320. And then we add and subtract, which gives us 312. Questions? A variable is a letter that is used to represent a number. Sometimes variables can be scary for students, especially as we start to use more and more of them, but it's just a number. So however numbers behave, variables should behave the same way. It's just that we don't know what number it is, so we put a letter there instead. But it is just a number. An algebraic expression is like that numerical expression, so it can have numbers, operations, and grouping symbols, but it can also have variables. It still does not have an equal sign. Once we start writing equals, that turns it into an equation. So in evaluating these expressions, what we're going to do is take the number given and put it in x's spot, in parentheses. So I'm going to put a negative 2 in for x, and I'm going to put it in parentheses. As we saw in our very first couple examples, those parentheses can make a difference. So that's why it's important that when you substitute in a number for a variable, that you put parentheses around it. Because now as we work through our order of operations, there's nothing to do inside of the parentheses, so then we'll do our exponents. And when we do that exponent, this turns into a positive 4. Whereas if we didn't do the parentheses, we would have a negative 4. So parentheses are important. So then we do our multiplications. Negative 12 plus 10, double negative. And then we do our additions and subtractions as we work our way through So we get negative 2 plus 7, which is 5. Okay. Questions?
What do you do with the 6? Wait. Oh, just kidding. Did that wrong.
All right, go ahead and try the next one. So I'm going to plug in a negative 3 for each x. And I put the parentheses around it. As I work the order of operations, the first thing I need to do is the exponent, which gives a positive 9. Then I do the multiplications, negative 36 and negative 18. And then the addition and subtraction, put all those together, which gives negative 59. As always, feel free to use your calculator to help you out there if you need to. Questions? You have $50 and are buying some movies on DVD that cost $15 each. Write an expression, so that means we're not looking for an equal sign. Write an expression that shows how much money you have left after buying n movies. Then evaluate the expression when n equals 2 and n equals 3. When you read through a word problem, I would suggest at the end of each sentence you pause, and if there was a command in that sentence that you do it before you continue reading. Otherwise, students tend to read the whole problem and only do the last thing that they were asked to do. Okay? We need to make sure we do everything we're asked to do. So the first sentence, you have $50 and are buying some movies on DVD that cost $15 each. There weren't any commands there, that's just some factual information. The next one, write an expression. That's a command. They're telling us something to do there that shows how much money we have left after buying n movies. So if I have $50 and I'm buying stuff, what kind of an operation would that be? Subtraction. So I've got $50, and as I spend money, I'm going to subtract out what I'm spending. I'm spending money on movies that cost $15 each, and I don't know how many I'm going to go buy. So what would show that? 15n. $15 for each of those movies, and I don't know how many I'm getting. So that's our expression. Evaluate the expression now when n equals 2 and n equals 3. So if I plug in a 2 for this thing, I get 50 minus 30 is $20 left. If I plug in a 3, I get 50 minus 45, just $5 left, and that maxes me out. I can't buy anymore. Questions? So make sure in your homework on word problems that you do everything that's asked. If it tells you to write an expression, I'm going to expect an expression in your answer, not just the final answers.
So the expression will be part of the answer.
The expression is part of the answer, yep. Each command needs to be done. Questions? Right. The next example is really exactly the same. We just changed to CDs 55 and 12, and so we're just going to skip past that. So it's really exactly the same. Like terms mean two things, same variable and same exponent. So x's are not like y's, and x's are not like x squareds. It has to be the same variable and the same exponent, and then it is a like power, and they can be combined. When we simplify, that's what we're looking to do, is combine any like terms. So if I have 7 x's and 4 more x's, altogether I have 11 x's, because x's are like x's. I can put them together. In the next one, though, I have some things that are alike and some things that are not alike. N squareds are like n squareds, but they are different than plain n's. To be alike, they have to be the same variable and the same exponent. So I can do the 3n and the negative, or 3n squared and the negative n squared. Gives me 2n squareds, and that plain n just tags along. Okay, so the n squareds I can add up 3 and negative 1, but the plain n, I can't put anything together with them. In the third one, what do I need to do first to get rid of those parentheses?
The claw
The claw thing, our distributive property. So we're going to take the numbers in the front and pass them on through. Gives 2x plus 2. Now here you need to be very careful. Super common mistake. We are not going to pass out a 3. We are going to pass out a negative 3. Negatives are connected to the number that follows them. So don't just pass out the 3. That negative has to go along with it. We are going to pass out a negative 3. So that gives negative 3x plus 12. Make sure you connect negatives to the number that follows them. Now we can combine up like terms. X's are like x's. 2 minus 3 is negative 1. You can write the 1 or not write the 1. It doesn't really matter. And then our constant values, 2 and 12 makes 14. You could also write it as 14 minus x, and that's totally fine as well. I tend to write my variables in decreasing order. So I start with the highest power and then work my way down, but it doesn't matter as long as your signs are all with the right stuff. Questions? Last one. You want to buy either a DVD or a CD as a gift for 10 people. No commands there. That's just informational, so we keep on reading. DVDs cost $13. CDs cost $8. More information. Write an expression. That's a command. So now we're going to do something at the end of the sentence. For the amount of money that we must spend. Okay, so I'm going to buy some DVDs. I don't know how many. They're $13 each. How can I express that?
N times 13 times.
Okay, so 13 times N, X, D, whatever letter you like. Okay, 13 times something is how much I'm spending on DVDs. And I'm also going to spend money on something else. So how do I express that?
8.
Plus 8 times, now I don't want to bring in more variables than I have to. So I'm going to buy maybe a different number of CDs than DVDs, so I can't just use N again, but I don't want to start using a new letter unless I really have to. In the first sentence, we're told that we're buying gifts for 10 people. So if I buy 2 people DVDs, how many CDs am I getting? 8. If I buy 4 people DVDs, how many CDs am I getting?
6.
6. What are you doing to find those answers?
Addition.
So if I buy 9 people DVDs, how many CDs? 1. What did you just do? Subtraction. We did 10 minus the number that we've already bought. And that way we don't have to bring in a new variable to the problem. Evaluate the expression when 4 people get DVDs. What does N represent in this problem? Is N DVDs or CDs?
Both.
DVDs. Okay? So because it's with the 13 and it's the first thing that we did, it's DVDs. So just make sure you know what your variables mean, because if this said evaluate the expression when 4 people get CDs, then you have to think about what you're going to do about that. Okay? So don't just go and plug it in for whatever. Think about what your variables mean. But we can plug that 4 in for the N. Order of operations, we do our parentheses first. Then we do our multiplications, which gives 52
Yes.
and 48, which is $100 even. All right? Questions? Your homework comes from lesson 2 tonight. Make sure you notice that this 39 to 51 at the end of it is multiples of 3. Okay? That 39 to 51 is multiples of 3. Make sure you notice that, otherwise you're going to end up doing a whole lot more than you need to.